Greetings and welcome. In this session, you will be able to solve numerical on hydrostatic law. Let us discuss about hydrostatic law. Hydrostatic law states that the rate of increase of pressure in vertical direction is equal to specific weight of fluid element. This is a fluid having height small h. So mathematically, by hydrostatic law, delta P by delta H or dP by dH is equal to specific weight gamma. Further simplification of this gives intensity of pressure at a point means P is equal to rho into G into H, where rho is density of fluid, G is acceleration due to gravity, and H is height of liquid column. Let us see first numerical. Find the pressure due to a column of 0.4 meter for oil of density 800 kg per meter cube, water and mercury of specific gravity 13.6. So in this numerical, these are the three fluids: oil, water and mercury, for which we have to calculate pressure intensity. So by the definition, pressure at a point P is equal to rho GH. For the oil, density is given 800 kg per meter cube. So P is equal to, putting the value of rho for oil, value of G is 9.81, value of H is 0.4. Doing the calculation, we get pressure intensity of oil in Newton per meter square or Pascal. Same calculation we can do for water. In this case, for the water, density rho is taken 1000 kg per meter cube. Value of G and H are same as of oil. So doing the calculation, pressure intensity for water in Pascal we found. Third, for the mercury, specific gravity is given. By the properties of fluid, there is a formula. Rho of any fluid is equal to specific gravity of that fluid multiplied by density of water, means standard fluid. So here rho of Hg is equal to specific gravity into rho of water. Specific gravity of mercury multiplied by rho of water 1000. So by doing the calculation, we find first of all density for the mercury in kilogram per meter cube. This we use in the further calculation of pressure intensity. So putting the value of density of mercury, values of G and H are same as of oil and water. So we find pressure intensity for mercury in Newton per meter square or Pascal. Next numerical is on hydraulic jack. So here the diameters of small piston and large piston of hydraulic jack are 3 cm and 10 cm respectively. A force of 80 Newton is applied on the small piston. Find the load lifted by the large piston when. Here are two cases. First, the pistons are at the same level and small piston is 40 cm above the large piston. Assume the liquid in the jack as a water. So first case we will see when the pistons are at the same level. So here in this diagram, on the left side, larger piston is of 10 cm diameter. Right hand side, small piston is of diameter 3 cm. As per the Pascal's law and the piston levers are same, we have intensity of pressure transmitted equally in all direction. So P is equal to, here we can write F1 upon A1 ratio for the force to area of small piston is equal to F2 upon A2 ratio for the large piston of force and area. Now area is pi by 4 into d square because the cross section of this is circular, that is cylindrical. So pi by 4 d square. So pi by 4 d1 square, that is for small piston. Pi by 4 d2 square is for large piston. In this case pi by 4 is getting cancelled. Remains, that is F1 by d1 square is equal to F2 upon d2 square. F1, that is a force applied on the small piston, is given 80 Newton divided by, this is the diameter of small piston, is equal to F2 unknown divided by large piston diameter. Now these diameters are to be taken in meter, so that's why convert that diameters from centimeter to meter. So doing the calculation we find that is load lifted by large piston, that is F2 in Newton. Then the second case, when the pistons are at the different level. Here in this diagram we see the larger piston is at low height than the smaller piston by 40 centimeter. So here for that we will write the formula. Pressure in a right column will be equal to pressure in a left column. In this case large piston will be taken as a reference line or datum line. So for large piston, here the pressure intensity will be P2, that is equal to pressure intensity at this smaller piston will be what? Pressure intensity P1 plus pressure due to liquid height, that is rho g z. Here z is taken for the height difference or level difference. Further, P1 is a ratio of F1 upon A1 and P2 is ratio of F2 to A2. So putting the values, F1 means force on smaller piston 80 Newton divided by pi by 4 into, this is the diameter in a meter, 3 centimeter diameter is given but we have to take in meter, plus value of rho. Here the liquid in this jack is said as a water, that's why density of water 1000, value of G 9.81 and Z means height difference 40 centimeter, that value in a meter means 0.4 is equal to F2 that we have to calculate, divided by pi by 4 into diameter of larger piston, that is given here 10 centimeter, so in meter 0.1. So putting all the values and doing the calculation we find value of F2, that is load lifted by large piston in Newton. Now in this case here, along with Pascal law, means pressure intensity at a point in a magnitude is the same and it is acting in all direction. This is Pascal law, but because of level difference here this rho g z, this also come in a picture. This is what hydrostatic law concept. So to solve this numerical we have used Pascal's law as well as hydrostatic law. So at the end of this session you can solve numerical on hydrostatic law. Subscribe the channel for further video sessions. Thank you.